Today we're going to do a crash course on Seaborn, a data visualization package in Python which makes it super simple and easy to create statistical graphics. It's based on Matplotlib but much easier to use, and it's much easier to create complex looking and advanced graphs. In this video we're going to mostly cover the different plot types. I'm going to explain how they work and how to customize them, and we're going to look at some styling options. If you like this video, let me know by hitting the like button and subscribing, but now let us get right into it. Alright, so we're going to do a crash course on Seaborn, and I want to get started right away. As I already mentioned, Seaborn is a data visualization library for Python built on top of Matplotlib, and it makes it super easy to create statistical visualizations of datasets or of data in general. Now in this video today, I want to cover as much as possible in a short amount of time, which is why I want to get started right away with the environment setup. For this, open up your terminal, navigate to a directory of your choice where you want to be working in. In my case here, that is going to be the tutorial directory. And here now, make sure you have Seaborn on your system. You can do that with your basic Python installation by just doing pip or pip3 install Seaborn. And we're also going to need a second package called JupyterLab. This is going to be our development environment. This is what we're going to use to work with interactive Python notebooks. And in my case, since I'm not using the system level Python installation, I'm going to say uv-init, and then I'm going to install these packages with uv-add. But in your case, if you're just using your basic Python version, pip or pip3 install these packages. So uv-init and then uv-add the same packages, Seaborn, JupyterLab in my case. If you want to, you can also use uv. Once you have this, you can just run JupyterLab, and in my case, I have to do uv run JupyterLab to make sure I'm using the version of this particular environment here, and then this opens up JupyterLab in my browser. So you can move the terminal somewhere else, don't close it, and now we can get started by creating a new IPython notebook. So just click on this button here, you can save this. I'm going to call this main.ipynb. I'm going to make it full screen, zoom in a little bit. And for those of you who have never worked with interactive Python notebooks before, the idea is quite simple. Instead of having one Python file where you run everything from top to bottom every time, you can run individual cells of code. So I can say here a equals 10, then I can say print a as a separate cell, and then I can say a equals 20, and then I can go back and just run this cell here, and then I have 20. I don't have to run everything from scratch every time. The reason this is useful is, or the reason it's useful in machine learning and data visualization, data analysis context is because oftentimes we do something like loading the data, pre-processing the data, training a model, evaluating a model, and then you want to just do some small thing in addition to what you already have. You want to add an additional graph or something, and then of course you don't want to have to rerun everything from scratch. So what we're going to do here first is we're going to say import Seaborn as SNS. This is the go-to alias. This is the alias that is used in the documentation and all of the code examples. This is just Seaborn imported in a shorter way. And the first thing I want to cover now is how to set the theme, what the different color palettes look like, and how we can choose the styling of our plot. Then we're going to go into loading datasets, and then we're going to cover the different plot types. This is going to be the structure of this crash course today. So the first thing is we can say sns.set_theme, and then we can choose a theme name by saying style equals and whatever the theme is that we want to choose. Now, the full list of available themes is available in the documentation. You will find a link to it in the description down below. But first of all, let's see what a graph looks like without setting a particular theme. So I can do something simple like sns.scatterplot, and then I can provide the x values 1, 2, 3, and the y values 1, 2, 3, nothing too fancy here, very basic stuff. And if I do this, you can see we have a very basic Matplotlib-like looking graph, like a scatterplot basically. But if I say here now, style is equal to dark grid, which is my favorite from the defaults, then I can rerun this and you can see we have a different layout, a different style here. So you can play around with that. You can try the different styles that are available. This one is my favorite. It has a light gray background here with a grid, and that's, I think, more pleasant for the eye. So in addition to that, we also have so-called color palettes. So I can go and say sns.color_, palette. And if I just run it like this, we will see the default palette, which is blue, orange, green, red, and so on. But we can also provide a specific name if we want to. So I can go and say, for example, one of them is called set 2 as far as I know. So we have set 2. I'm not sure if we have set 1. Yeah, we do have set 1, set 2, then set 3. And you can play around with this and see which one you like. There's also, I think one is called paired. This is this one. Then we also have stuff like HLS. And then you can provide a number. So that is a color spectrum. And you can provide a number to specify how many colors you want to have. So that's also kind of interesting. And then we also have stuff like rocket, for example. So you have different names, also something you can look up in the documentation. The cool thing is you can also make this continuous. So you can say here that this is the palette you want to use, and then you can say CMap equals true, or I think it's called as CMap equals true. And now you have essentially this as a spectrum instead of just having distinct colors, discrete colors. Now, the interesting thing happens when you set it. So what you can do is you can just say sns.set and then palette. And then you can choose to use one of these schemes. I personally am going to go with the default one. I just prefer it the most. But what you would do here is you would either provide the string or you would provide the palette object. So you could do SNS color palette, and then you could define it here, and then you can pass it to set palette if you want to. I'm not going to do that. I'm going to go with the default. And this is what we're going to use for our plotting. And by the way, I think the default is called deep. So I think if we do that, we should not change anything. All right, so that's the initial style setup. Then we're going to also load the data sets that we're going to use today from Seaborn. Now, this is not mandatory. You can use a pandas data set from anywhere. You can load it from a CSV file. You can get it from the web. You can load it from scikit-learn, from TensorFlow. We're just going to keep it simple today, and we're going to load them directly from Seaborn. So these are mostly basic data sets that you probably already know if you did some data science in the past, but you can do SNS .load dataset, and then you can just provide the name of the dataset. Now, if you don't know what datasets are available, you can just say sns.get dataset names. This is going to list all the datasets that are available, but for the most part today, we're going to use the tips dataset. So this is basically how much people are tipping in a restaurant, depending on what the total bill is and the gender and whether they're smokers or not, and the day that they went for dinner and the daytime also. So that is the data set essentially, and we can do some visualization stuff with this data set. So now we can move on to the core part of this crash course, which is the different plot types and how to do plotting using Seaborn in general, because the approach is a little bit different to that of Matplotlib. In Matplotlib, a lot of stuff has to be done manually. We need to say, I want a legend. I want to display this feature in this way with this color and this styling and this extra visualization. In Seaborn, we can also style a lot manually, but most of the stuff is done for us automatically by just providing the features that we're interested in. So let me show you how this works. Let's go and say tips data. I'm going to save this now in a variable is going to be equal to SNS load datasets, and it's just going to be tips. And now let's go with a simple scatter plot. So I'm going to say here SNS.scatterplot. And we're going to provide, in this case here, just the data set. And now we're going to say on the x-axis, I want to have a certain feature. And on the y-axis, I want to have a certain feature. So I'm going to say on the x-axis, I want to have the total amount of the bill. And on the y-axis, I want to have the tip. So if I do that, I will get a scatter plot that looks like this. The more money you spend, the more you tip usually. Makes sense. This is a positive trend. And that is a simple scatter plot. Now, what we can do with Seaborn that is not so easily done with Matplotlib is I can say that I want to vary aspects of this visualization based on certain features. For example, I might want to say that the gender should color the points differently. So if it's male, I want to have a certain color. If it's female, I want to have another color. Now, how do I do that without doing any fancy color codes? I can just say hue is equal to, and then the name of the variable, in this case, sex. And if I do that, you can see I automatically get this visualization here with a legend, male, female, and the colors represent this particular feature. Now, I can also do the same thing with the size. I can say that the size of the group should determine the size of the data point. So I can go and I can say size is equal to size. Run this, and now I have differently sized points just by providing the name of the feature here. All based, of course, on the dataset being present as a data frame. And I can do that with different things as well. So what else do we have? Maybe we can say that the smoker should determine the style. So I can say style is equal to smoker. Is it a smoker or not? And if it's a smoker, I get a circle. If it's not a smoker, I get an X, a cross basically. So that is also a customization option. And that is how Seaborn works in a nutshell. We have the different plotting functions, and there are a lot of different plotting functions. And the aspect that we want to link to a certain variable, we just have to provide the variable name for that specific aspect. This is super convenient and it's not possible like this in Matplotlib. Now, another thing that's interesting is we have figure level functions and axis level functions. Scatterplot is an axis level function. We just do one axis here, one visualization, and that's it. We can do the exact same thing that we did with the Scatterplot function with a different function called Relational. And Relational basically does the same thing, but we can use it with multiple different modes. So I can say, or different kinds, I should say. So kind is equal to scatter, for example. This is going to result in basically the same plot. We do have some differences here, like the legend is outside of the actual visualization here, but essentially it's the same effect. We have a scatter plot with all the same parameters, just that we have to provide the kind scatter, which also implies there's other kinds of visualizations that we can use here. But one thing that we can do with such a relational plot here, and which is not possible with a scatter plot, is we can have multiple axes here, multiple plots, so to say, in one figure. And not only that, we can also say that the split into different graphs should happen based on a feature. So for example, I also have the feature day here. We have Thursday, Friday, Saturday, and Sunday, and I could say that I want to have 4 different graphs for these days. How do I do that? All I have to do in the Relational function is I have to say column is equal to, or col is equal to day. This is now going to take this and make 4 different plots that represent the same graphic as before, but split into 4 different days. Now, if this is not what I want, I can also go and say column wrap is equal to 2. Then I would have a 2x2 grid, and I can see this a lot easier. And I can, of course, exchange all of this. So I can say, for example, that the color should be based on the day and the column should be based on sex. And then I would have 2 graphs and many more colors. So that is the basic idea of working with Relational versus Scatterplot. There's also Lineplot, which has the same effect as calling Relational with kind line. I'm going to show you that now. So if I say, let me use a different data set for this, Dow data, for the Dow Jones data, I'm going to say SNS load dataset, Dow Jones. This is just a stock index. So we can take a look at this data as well. Dow data. That is just the stock price, or the index price, I should say. And now I can go say SNS Lineplot, Dow data. And I can say X is equal to date and Y is equal to price. That's basically it. We get this line chart. Same thing happens if I do this with Relational and kind line. So Relational kind line has the exact same effect as this. Again, looks slightly different, but I can also do the same thing with scatter, of course, which doesn't make a lot of sense in this case, but it's possible. So Relational can be multiple plots, Lineplot and Scatterplot, but we can also split by column and or split column-wise based on a feature, which is quite convenient. And this also exists now for different plot types. Relational includes scatter and line, but we also have, for example, displot, so distribution plot. I can go and say sns.displot. This is not dist, so without a T, it's displot. And I can say I'm interested in the tips data, and I'm just interested in the distribution of the tips. So I can do that, and I immediately get a histogram without even providing the kind, because that's the default. I can say kind is equal to hist, which will have the same effect. And of course, you guessed it, I can also go and just do histplot directly. So I can say histplot like this without the kind parameter, and it's going to be roughly the same visualization, just a different figure size. So we have displot, histplot. But of course, what can I do with this plot that I cannot do with Histplot? I can split based on a feature into multiple plots. So I can say here that the column should represent the different genders. And now I have two histograms, which is not possible with the Histplot. However, what I can also do in the Histplot is I can say that the color should be based on sex, and then I would have the two histograms in front of one another with some transparency. This is something that I can do. And this displot function also now contains more kinds than the relplot function. So another plot that I can do is I can say SNS KDE plot. I'm not even sure what KDE stands for. I knew it once. But basically, it's like a histogram, but as a continuous line. So I can say tips data x is equal to tip. And then we get something like this. But the cool thing is, it's not just that I can do this with one variable, like a histogram. I can also turn this into a kind of contour plot by providing a second variable. So I can say that the total bill should also be represented here. And I can say plot, then I'm going to get it like this. And theoretically, I could also say that the color should be determined by gender. And then I would have two of these plots on top of one another. And depending on what you're trying to show here, you can of course play around and do different things. What we can also do here, I think there's a parameter called fill. Then this looks a little bit more professional if you do it like this. We could also say maybe that the color represents the days. This is also possible, but then of course maybe you need to work with some transparency here manually, but you get the idea. With all these plots, we have the data and we have different parameters, and all we have to do is we have to pass feature names, and then we can do some custom stuff. I recommend with all of these functions, if you want to go deep into one of them, if you want to style very specific aspects of them, you either need to go onto the Matplotlib level, so you can use Matplotlib in combination with Seaborn, since Seaborn is built on top of Matplotlib, but also you can go to documentation and see what parameters there are. I'm not going to cover all of these functions in detail, but I'm going to show you how they work, what you can do with them on a basic level, and then you can go deeper into them if you want to. And of course, what you can do here with a KDE plot, you can also go again and do it using this plot. And then you can just say kind KDE, same result, but you can also now split by column and say, for example, column is sex, and then you would have two plots side by side. That is again the difference between this plot and the child functions, or I should say the axis level functions. So another function that we can plot or use here is the ECDF plot, which is like a cumulative density. So I can, or cumulative probability, I can say again tips data, and then x is equal to tip. That is basically not the histogram, but the cumulative probability, which essentially means that the probability that a tip like this or lower has been given is this probability, and the probability that the tip was $6 or more or less is like 97%. The probability that the tip was $10 or less is 1, so 100%. And of course, this also works with this plot and kind ECDF. Now, there's also one additional plot type which doesn't work on its own. You add it to a histogram, for example. So we can maybe go up here, copy this, and in addition to that, we can also now call an additional function called rucplot. So that would be sns.rucplot. You do that in addition to histograms, and then you can say tips data x is equal to tip, and color could be something like orange, for example. And what this is going to do now is it's going to plot, and of course this now doesn't work if I'm splitting on a column basis, so let me do it like this. This now plots the individual data points onto the histogram. So it's not just the density, it also shows you the actual values. So it's not just between 2 and, I don't know what the boundary is here, 2.3 or something. It's actually, you see the individual data points here. Now then, the next figure level function is catplot, so categorical plot. For this, we can do sns.catplot. We can go again with the tips data. And here now I can do, for example, tip on the different days. So the y is the day. And I can say kind is equal to a strip plot. So that basically shows me the different tip values. It's a little bit like the ruck plot, but in a different way, visualized in a different way. So we have the different tip values on the different days of the week. And then we can also say, again, hue is based on male, female, if we want to do that. And I think it goes without saying that this is the exact same thing as just calling strip plot directly. So if I say SNS strip plot, I just have to remove the kind. But besides that, it's going to be the same thing with a double P, of course. An alternative plot to that would be the Swarmplot. It's quite similar, but a little bit different because there we have the values more like vertically lined up. But of course, that also works with Catplot and then with kind swarm. Then one of the plots that probably most of you guys know from school is the Boxplot. You can either call this using the Boxplot function or by saying Catplot kind box. That's also possible. There we can say just use the tip as the value, then you get one Boxplot. Then you can also say, okay, use it based on or split it based on the day, like this. And basically a Boxplot shows you the median, the different quantiles, and also some outliers, the min and max that are not outliers. Yeah, if you don't know how to read this, you can Google it. The basic idea is this is the minimum value, this is the maximum value. Then you have some outliers which are not considered to be part of minimum and maximum. Then you have like the first quartile, the second quartile, which is the median, and then the third quartile. And then you can see the range of the individual individual segments here. And an alternative to this plot type is also the violin plot. That shows you the distribution in this curvature, and you can also see here the median. Another one would be the Boxen plot, which shows different size of boxes here. So as far as I remember it, it's like you start with the median here, and then each portion, so each next line is like half of the remaining data. Not sure if that's precisely correct, but it's usually something that you use for larger data sets. I've never used this for data analysis myself, but doesn't mean that it's useless. It's probably quite useful if you know what you're doing. Then there's also the classic bar plot. So a bar plot is just bars. You can either have horizontal or vertical bars. But for example, we could do something like X is the day and Y is the tip. That would be now a vertical bar chart. Then you can also say easily that the color is based on the gender. And this is the beauty of Seaborn. You don't have to take care of the alignment here. You don't have to think about how to structure this. You don't need to invent color codes. You just say, I want to have an additional factor here. There you go, you have it. And since we have more than one value here for the tip per day, this is shown as a range, and this is basically always the middle of this range. That's how you do a bar plot if you don't have just one value per day in this case, or per X value. An alternative to that would be the count plot. With the count plot, we don't get a lot of information, but basically if I just say X is equal day, we see how many instances we have per day. We can also say, for example, that the color should again represent something like sex, for example. And then you can see that this is also split to be counted correctly, to split the count up into the different genders. And the last categorical function that I would like to show is the point plot. The point plot is also showing a distribution, or also showing a range, I should say. So we can say X is equal to the tip and Y is equal to the day. And then basically we can see on Thursday, that is the range of tips. On Friday, that's the range of tips. And yeah, that's basically how you can do that. You can also, of course, again, add colors based on the different features and see how they overlap, see how they change or how they differ. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring. If you want me to teach you personally something that you don't understand, if you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. Now we move on to something more exotic, which is a Jointplot. So we can say sns.jointplot, and what this is going to do is we're going to provide the tips data set again. Let's say X is tip and Y is total bill. Then we can see, first of all, we get a scatter plot like in the beginning, but now we also get a histogram for the respective feature here. And this is also aligned with the point. So we can see the tip, or actually, I think maybe we should do it the other way around because that's how we had it in the beginning. Total bill, and then y is equal to tip. We can see that here the total bill is spread like this, and we have a lot of points here, which is also represented in the histogram. Same thing here for the tip. We have a lot of tips down here, so here we get the highest activation in the histogram. That is quite useful for data exploration. Now, even more exotic than that is the Pairplot. So I can just say SNS Pairplot and provide the entire data set, tips data. And this is now going to plot all the numerical feature against one another. If they're not pre-processed, they're not going to be used. So if you're not using, if you don't somehow encode day as 1, 2, 3, 4, or if you don't encode smoker as 0 and 1, it's not going to be used. But we can see that size, tip, and total bill are used because they're numbers and they're plotted against one another. If it's the feature plotted against itself, we see the histogram. Otherwise, we see a scatter plot. But one of my favorite use cases when it comes to Seaborn is the heat map. The heat map can be used for a number of different things. And one of the favorite use cases for me is plotting correlations. So when I do data exploration, oftentimes I want to know how certain features correlate, especially if I plan to do machine learning on them. And for this, I'm going to use a different data set now to show you how I usually do that. I'm going to use the Titanic data set. Titanic is equal to SNS load dataset, Titanic. And in order to calculate the correlation between the features, they need to be numeric. Like for the Pairplot, they need to be numeric, but it's not possible to do the correlation between age and embarked, for example, if you don't encode embarked, or class, or adult male, and whatever you want to use here. So I'm going to pre-process some of the features here. This is now not Seaborn. This is more like Pandas pre-processing, but it's going to be necessary to calculate the correlation, which is what we're going to visualize with a heat map. Now, since this is not a central part of the tutorial, I'm going to copy paste this to not waste too much time here. I'm basically encoding the binary features. So we have sex is either male or female, so 1 or 0. Alive is either yes or no, so it's going to be 1 or 0. And alone is going to be either true or false. So we're mapping a Boolean to the integer world. And then we do two more things. We encode the class from first, second, third by using the categorical D type from Pandas. We're encoding this to be 1, 2, 3 essentially, or 0, 1, 2 actually. And then we're dropping all the other features. By doing that, and of course I need to call this Titanic data. By doing that, and also by importing Pandas SPD, we get a Titanic data frame that contains only numbers. And what we can do now is we can calculate the correlation. So for this, we're just going to say Titanic data dot core, so dot correlation. And now we can see how the features correlate with one another. We have 1 always on the diagonal because the feature is exactly the feature itself when it's compared to itself. But other than that, we get values between -1 and 1. I think you know how correlation works, but it's not clear to me. I don't see immediately here very strong correlations with my eyes unless I really look for them. I can see maybe that this is quite high negative or strong negative correlation, but it's difficult to spot the correlation. So what I like to do is I like to use the heat map from Seaborn, which is sns.heatmap, and then I just pass Titanic data.correlation, for example. And by the way, this can be used for any table data that you have. It doesn't have to be a correlation table, but I can do it like this, and it immediately gives me a heat map. Now, with this heat map, I have the colors, and I can read the colors and easily spot certain values, but I don't know the actual values. So what I can also do here is I can provide annotation is equal to true. So annot is equal to true. That is now going to also give me the numbers. And since this is not easily readable, we can also now include Matplotlib here. I can say import matplotlib.pyplot as PLT, and I can say PLT figure size is equal to 12.8, for example, just to make it a little bit larger. And now I have this proper heat map. Now, maybe it's confusing to you because you don't like the colors. It's not clear to you what is high, what is low, and you always have to look at this legend. It's more intuitive maybe to use a different color map. For example, we can say CMap is equal to, and this is something that you can also find in the documentation, you can just say cool warm. that would be from red, very strong positive correlation, to blue, very strong negative correlation, and in the middle you have like gray, which is kind of neutral. So if something is very blue, I can see, okay, there's a lot of negative correlation. If something is very red, I can see a very positive correlation. And by the way, by doing this, I can see that I made a mistake in the pre-processing because alive and alone have a correlation of 1. This is not possible. They would be the same feature, and they are because I didn't correctly change the code. So let's do all of this again, alone, and now I should get a different correlation there. There you go. Now, there's also another plot type which I think is quite exotic called a cluster map. And for this, I want to use a different data set, the iris data set. Probably you know it if you have done machine learning before. Basically just a data set with flowers. They have different species and different lengths and widths of certain features, sepal length, petal length, I'm not sure how it's pronounced. But basically we can say SNS load dataset, iris, and then we can do a cluster map of the iris dataset. So let's take a look at the iris dataset. We have these 4 features, different lengths and widths, and then we have the species. What kind of species is this? And what I can do now is I can say SNS cluster map. But of course, since I'm clustering, I'm not interested in the species because these would already be classes, and clustering is always like unsupervised. So what we're going to do is we're going to actually take iris and we're going to drop the species. So I'm going to say species drop on axis equals 1. Now this requires SciPy to be available. So I think for this one, we need to actually install a SciPy. So let's go to the tutorial directory, uv add SciPy like this, and then run this again. Probably we need to restart the kernel for this. So let's go to the very bottom. Let's import again. Let's go down again and let's run this. And for this, of course, I need to load iris again. But there you go. Now we have this fancy cluster map. And in the beginning, it might be a little bit difficult to understand what is happening here, so I'm going to try to explain it. On the right, you just see IDs, so you can, for the most part, ignore these. These are not very important. What you have here on the x-axis is the 4 different features, and what you have on the y-axis is all the different individual rows of that data frame. So everything you see here, every line, no matter how thin it is a row, which is one specific flower, so one specific measurement. And every column is the feature. So basically in one row, you have the 4 different features, and one cell is an activation for that specific feature of that specific row. And here you can see what the activation actually means. But I think this is actually scaled so that the features do not differ too much from one another, if I'm not mistaken. But the basic idea is that you have clustering, which basically means the things that are closer together are more similar. So in the beginning, you have this split here. You have all the data from here to here. That is one group. So from here to here is one group, and the other group is from here to here. Then you have a second split here, which is into this, and you can go to the lowest level to see that this is basically from here to here, and then also from here to the very bottom. So the first cluster is actually this one here, which is orange, black, pink, and dark purple, I would say. And then the second cluster is like orange-ish, dark purple, pink again, and like orange-purple mixed. And then within these clusters, you have other separations. And this basically just means that this is what the data looks like if you split it into similar groups. Now, how deep you want to go with the split is up to you, but you can see what the data looks like if you cluster it into similar instances. And for the features, you can also see that basically these 2 features here are the closest to one another, the most similar in terms of the patterns that appear in the different instances. And these 2, like this length and this length, are basically the most dissimilar. And now finally, the last thing I want to show you about Seaborn is the 2 functions Lineplot and Regplot, basically the same functions again. One is figure level, one is axis level. But if we do sns.lineplot, and then we provide, let's say, tips data, and I think I need to load this again since I restarted the kernel. So let's go and do that. But basically, this Lineplot performs a linear regression. So I can say that I want to look at total bill again and the tip. And that is going to now fit automatically a regression line. I can still go and separate the color by gender, for example. That is possible. then I get 2 lines and two regression fits, which we can see the trend is pretty much the same. But that is also possible to do linear regression automatically with Seaborn. And we can also do the same thing, as I said, with the regplot function. The Lineplot is the figure level function. So actually, this is interesting. I didn't know that the regplot function doesn't offer the hue argument. So that's also a limitation. But with the Lineplot function, we can do hue and we can also do column day, for example. That is also possible. And then we have 4 different regression line, or 2 times 4 different regression lines. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested in any freelancing services or tutoring, on my website you can find a tab for services and for tutoring. There you can contact me for projects that you need help with, for tutoring if you want to be taught one-on-one. And you can contact me via LinkedIn or email. At the bottom, you will find the 2 buttons. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.